fabulous AP Statistics students. Today we are starting Chapter 7, 7.1a. What is a sampling distribution? So the first thing you need to know is some vocabulary. The first word is population and the second word is sample. So a population includes all members of a specified group. These could be people, they could be some sort of animal, it could be length of something, it could be anything that the researcher wants to study. That's the population. The sample is a subset or a subgroup of the population. So you can see here on the left, our population is all possible Avengers. And to the right, we have many different types of samples or subgroups. The sample is usually, hopefully, taken with some sort of randomized approach that we learned about in Chapter 4. So when I have a population, I can calculate sometimes a parameter. And a parameter is some sort of number that describes a characteristic of the population. However, normally we cannot find a parameter on an entire population, as that would be too cumbersome. So instead we find a statistic, which is a number that describes some characteristic of the sample that we took, and it's often used to estimate the actual population parameter. So here's kind of a little visual of what we're talking about. If your population is this large cloud here, that is the population from which I'm trying to sample. And hopefully, using some of the methods we learned in Chapter 4, we take a good sample. If we take a bad sample, then we won't have as good of estimation techniques. So from our population, possible parameters could be, for example, mu, which equals your mean of the entire population, p, which is a proportion of some sort of the population, and sigma, which is the standard deviation of the population. Those are all examples of parameters. There are more types of parameters, but these are the three main ones we will be using this year. And from that, if I take a sample, I can find statistics that can estimate those population parameters. The statistic that estimates mu is called X bar, which is our sample mean. So if I take an average on a sample, that is called X bar, and that estimates the mu mean. If I take a sample proportion, we call that P hat. Notice it's a P with a little hat on top. So P hat estimates the population proportion. And S is the sample standard deviation, which estimates sigma. Now you can take all these statistics on the bad sample as well, but you won't be having a sample that's as reliable, so these statistics will not be as good estimators of the parameters. Here's a table you might want to screenshot or copy down in your notes, which gives the symbol we use for the population parameter and its corresponding symbol we use for the sample statistic that usually is used to estimate that parameter. We will be using these a lot in the following chapters. Okay, so here's an example problem to try to differentiate. Why don't you pause here and read it and see if you can fill in the blanks. One thing you need to remember is when it asks for a population, it's not asking for a number, it's asking for a description of the population. Same thing with sample. It's not asking for a number, although you can use the number to describe it, but the sample is a description of what the sample is. So here's your example. A production run of ball bearings is supposed to have a mean diameter of 2.5 centimeters. An inspector chooses 100 bearings at random from the run. These bearings have mean diameter of 2.5009 centimeters. So pause the tape right here and think, what is the population? What is the parameter? What is the sample? And what is the statistic? Okay, hopefully you figured out the population is the entire production run of ball bearings. And notice we don't know how many there are. It's not given to us, so sometimes that is true. The parameter is the ball bearings mean of the entire production run, which is mu equals 2.5 centimeters. The sample is the 100 randomly chosen ball bearings from the run. So the sample size is 100, but the description is it's the randomly chosen ball bearings from that run. And the statistic is the mean diameter from that sample of 100, which we will call x bar, which equals 2.5009. So hopefully you got those all right. And remember, statistics bullying is no joke. Have a great day.